It was April 7, 2003. The aircraft was flying fast, too fast. Captain Eric Dass and Major William Watkins were aboard one of the most advanced flying machines ever built, the F-15E Strike Eagle. Their mission was desperate and critical, to support U.S. Special Forces engaged in fierce combat at Tikrit, Iraq. The F-15E Strike Eagle, a marvel of engineering, could reach blistering speeds of Mach 2.5. It was armed with a dozen laser-guided missiles, equipped with an APG-70 radar capable of detecting hostile forces from great distances, and 2 lantern pods that could strike targets with pinpoint accuracy regardless of the weather. As they soared through the skies, Dass and Watkins understood the gravity of their mission. The fate of their comrades on the ground depended on their success. Every second counted. They knew that once they reached their destination, it would only take moments to locate their targets and unleash their deadly payload. Their hearts raced, knowing that failure was not an option. The lives of many hung in the balance as they sped toward their target with unwavering resolve. However, they were not prepared for the overwhelming anti-aircraft fire surrounding the Iraqi city. The sky was a storm of deadly flak and missiles, and they knew they would need every state-of-the-art countermeasure in their arsenal to make it out alive. The F-15 Eagle, a legendary predecessor to the F-15E Strike Eagle, had paved the way for this moment. This American twin-engine all-weather tactical fighter aircraft was born to replace the iconic F-4 Phantom II, another creation of McDonnell Douglas. Conceived in the aftermath of the war in Indochina, the Phantom had been a reliable workhorse. The F-4 Phantom II, an all-weather aircraft designed as a long-range fighter bomber and supersonic jet interceptor, was a mainstay of the U.S. Navy, Air Force, and Marine Corps during the Vietnam War. Throughout that grueling 10-year conflict, the Phantom served as the primary air superiority fighter for the U.S. military. It took on numerous roles, conducting aerial reconnaissance, launching ground attacks, and intercepting enemy aircraft. The Phantom was crucial in saving countless lives of Allied forces pinned down by the overwhelming numbers of hostile North Vietnamese troops in the countryside. It relentlessly punished communist supply lines by conducting bombing runs over the Ho Chi Minh Trail. Despite its outstanding Mach 2.2 speeds, its heavy weapons load of over 18,000 pounds, and its devastating M61 Vulcan rotary cannon, the Phantom began to show its age after 2 decades of hard service. On January 9, 1976, McDonnell's F-15 Eagle took flight, essentially replacing the Phantom. The Eagle, with its cutting-edge technology and superior capabilities, continued the legacy of its predecessor, becoming the new guardian of the skies and a symbol of hope and power. The Eagle was designed to be the ultimate air superiority fighter, answering the USAF's call for a dedicated aircraft to dominate the skies. Although neither the Air Force nor the Navy initially showed interest in an F-15-derived interdiction fighter, McDonnell Douglas pressed on, envisioning a prototype that could one day replace General Dynamics' F-111. The vision began to take shape in 1978 when the USAF initiated the Tactical All-Weather Requirement Study, considering McDonnell Douglas's proposal as a potential future strike platform. By the following year, McDonnell Douglas and Hughes Aircraft were working together to enhance the F-15's air-to-ground capabilities. This new prototype was named the F-15E. In early 1981, the Air Force announced the Enhanced Tactical Fighter program to replace the aging F-111. The new aircraft needed to perform deep air interdiction missions without relying on jamming countermeasures or fighter escorts. McDonnell Douglas submitted the F-15E, General Dynamics offered the F-16XL, and Panavia Aircraft entered the Tornado into the competition. From 1981 to 1983, these aircraft were pushed to their limits. Under Brigadier General Ronald W. Yates, the program was renamed the Dual-Role Fighter Competition, highlighting the need for versatile capabilities. The F-15E underwent more than 200 test flights, proving itself highly reliable and capable of carrying over 16 different weapon configurations. After rigorous trials, the USAF chose the F-15E in February 1984. The Air Force awarded McDonnell Douglas a contract to produce 390 F-15Es. The first was delivered in December 1986, taking its maiden flight on the 16th with pilot Gary Jennings at the controls, soaring to an altitude of over 40,000 feet and reaching speeds of Mach 0.9. This initial F-15E still wasn't the final version. it lacked the redesigned engine bay and aft fuselage. It wasn't until April 1988 that the first fully completed F-15E was delivered to the 405th Tactical Training Wing at Luke Air Force Base in Arizona. Production ramped up steadily, and by the early 2000s, more than 230 F-15Es had been handed over to the Air Force. The F-15E Strike Eagle had firmly established itself as a cornerstone of American air power, a testament to innovation and perseverance in the face of immense challenges. The F-15E Strike Eagle stands as a testament to remarkable innovation and adaptation, diverging significantly from its predecessor, the air superiority-focused F-15. While retaining the ability to engage in air-to-air battles, the F-15E was primarily designed for air-to-ground missions, making it a versatile and formidable force in the skies. Though the F-15E maintained the basic airframe of the original Eagle, it underwent crucial structural changes. The aft fuselage was redesigned to accommodate more powerful engines, and the engine bay was modified using advanced technologies like superplastic forming and diffusion bonding. The cockpit was upgraded with the latest avionics and screens for radar, thermographic cameras, weapon status, and essential electronic warfare tools, all managed by the second crew member, the Weapons Systems Officer, WSO. This sophisticated setup allowed the WSO, or WISO, to have access to flying controls, complete with their own stick and throttle, ready to take over if necessary. The aircraft's navigation system was another leap forward, integrating a laser gyro and a global positioning system to provide precise, real-time information to both crew members. The APG-70 radar, a key innovation, enabled the crew to identify long-range ground targets with unparalleled accuracy. As the USAF describes it, one feature of this system is that after a sweep of a target area, the crew freezes the air-to-ground map and then goes back into air-to-air mode to clear for air threats. During the air-to-surface weapon delivery, the pilot is capable of detecting, targeting, and engaging air-to-air targets while the WSO designates the ground target. The name Strike Eagle was chosen to distinguish this advanced aircraft from its predecessor, underscoring its enhanced capabilities. With a top speed of 1,875 miles per hour, a wingspan of 42.8 feet, a length of 63.8 feet, a height of 18.5 feet, and a maximum takeoff weight of 81,000 pounds, the F-15E is a marvel of engineering and power. One of its standout features is the Lantern system, low-altitude navigation and targeting infrared for night, consisting of two pods attached to the aircraft's exterior. This system provides extraordinary accuracy in weapons delivery, enabling the pilot to fly safely at low altitudes using cues on the heads-up display provided by the terrain-following radar, TFR, within the pods. In every aspect, the F-15E Strike Eagle embodies the relentless pursuit of excellence, merging cutting-edge technology with robust design to create an aircraft capable of performing with unmatched precision and power in the most demanding conditions. Its development marks a significant milestone in aviation history, reflecting the dedication and ingenuity of its creators and operators. This unique feature can be combined with the Strike Eagle's autopilot capability, providing seamless hands-off terrain navigation. Meanwhile, the second pod is dedicated to targeting, equipped with a laser designator and tracking system that can mark objectives for destruction from long distances. The information gathered can be directly transmitted to GPS or laser-guided bombs, ensuring precision strikes. Ultimately, the Lantern system enables the Strike Eagle to fly at low altitudes in any weather conditions, delivering lethal precision to any target. These capabilities are further enhanced by the aircraft's formidable arsenal, including an internal General Electric M61A1 Vulcan 20mm cannon with 500 rounds. The Strike Eagle can carry almost every weapon in the USAF's inventory. Typically, it is armed with 4 AIM-9 Sidewinder, 4 AIM-120 AMRAAM, and 8 AIM-120 AMRAAM missiles for both air-to-air and air-to-ground operations. Additionally, it can be fitted with 2 conformal fuel tanks that hug the fuselage, reducing drag while carrying over 750 gallons of fuel. This extends the aircraft's range to over 2,400 miles, with a maximum service ceiling of 60,000 feet. Powering the Strike Eagle are two Pratt & Whitney F100 PW220 or 229 engines, providing over 50,000 and 58,000 pounds of combined thrust. These engines feature digital technology for increased performance, allowing the aircraft to reach maximum afterburner in less than 4 seconds, facilitating quicker takeoffs and agile maneuvers. The Strike Eagle saw its first deployment during the invasion of Kuwait in August 1990. As part of Operation Desert Shield, the 335th and 336th Tactical Fighter Squadrons were positioned near the Iraq border to attack enemy positions.